Screen. Screen കാണുന്നുണ്ടോ?
Yes, sir.
Okay. Okay, in the previous class, we were dealing with the powder metallurgy, the terms and the main characteristics. What are the characteristics of a metal powder? So, നമുക്കറിയാം ഒരു metal powder, we are creating the final product using powder metallurgy. We will see a basic animation. Before that, we will discuss something about the powder metallurgy. നമുക്ക് അതിൻ്റെ ക്യാരക്ടറിസ്റ്റിക്സ് പറഞ്ഞത് എന്തൊക്കെയായിരുന്നു? ഫസ്റ്റ് വൺ ഇസ് ദ പാർട്ടിക്കിൾ ഷേപ്പ്, അല്ലേ? സൈസ്, പാർട്ടിക്കിൾ സൈസ്, ഡിസ്ട്രിബ്യൂഷൻ, ഫ്ലോ റേറ്റ്, കംപ്രസിബിലിറ്റി, അപ്പാരന്റ് ഡെൻസിറ്റി, പ്യൂരിറ്റി. ഇത്രയും ക്യാരക്ടറിസ്റ്റിക്സ് ഉണ്ടായിരുന്നു ഒരു മെറ്റൽ പൗഡറിന്. ആൻഡ് ഡിപ്പെൻഡിങ് ഓൺ ദാറ്റ് the process properties etc. will vary. Now we will see the main step, basic steps involved in powder metallurgy. So what are the basic steps? Basic steps in powder metallurgy. What are the basic steps in powder metallurgy? First one, manufacturing of the metal powder. First of all, we are creating the metal powder. Second, blending and mixing. Of powders. Third, compacting. Fourth one, sintering. And finally, finishing operation. Okay, so first of all, the metal to be made, or the metal, using the metal, which metal we want to use for the final product, that metal, it should be powdered, or it should be made into fine powder. Then it is blended or mixed with some other particles also, because we are not just using a single metal powder, but we are adding some additives or some lubricants etc. in order to enhance their properties or increase the efficiency of the production. That is coming under the blending and mixing of powders. Then after that, this mixture is put into a die or whatever may be. Then a pressurized compacting or a pressure is applied to the powder, and it will combine together. That is compacting. Then sintering, that is by applying the heat energy, it will be the particles will fuse together to form the final shape. Then after that, finishing process like grinding, polishing, honing, etc. will be done on the final product. These are the main, so this is a 5-step process, powder metallurgy, and now you can see a basic animation for that. Just a minute.
Hello, hello.
Ah, okay. കാണുമ്പോൾ yes. Visible ആണോ?
Powder is used. Each of the ingredients that will
Yes, sir.
Okay.
metal powders used for parts production can be a combination of various elemental particles or pre-alloyed powder. If elemental powder is used, each of the ingredients that will comprise the desired part are mixed in proper proportion into a uniform blend. With pre-alloyed powder, the proper proportion of ingredients is already present in each particle. In either case, additives such as binders and lubricants are usually added. The powder is then consolidated in molds or dies, shaping and densifying it into a compact of the desired part. At this point, the part, or compact, is in a green state, where the powder particles are just lightly joined together. In this state, the parts have a so-called green strength, which is usually only sufficient for handling purposes. The parts are then transferred to a sintering furnace. During sintering, parts are heated at a temperature below the melting point or range of the base metal, but high enough to metallurgically bond the individual particles. Sintering further densifies the parts, increasing strength. Final part density is extremely important. Although controlled porosity is required and achievable for certain parts, the performance of structural parts increases directly with increasing density. The common methods of consolidating and shaping metal powder for parts production include mechanical pressing, injection molding, and isostatic pressing. Most parts are made by mechanical pressing and sintering. Parts are usually small to moderate in size and can be simple or complex in shape. They can be very thin or thick and can also have one or more levels, shallow or deep holes, and various other details. Parts produced by mechanical pressing can be net or near net in shape and have very close tolerances. Part production rates are high, from several hundred to thousands of parts per hour. In mechanical pressing, the powder is automatically gravity-fed into the die of a mechanical or hydraulic press and consolidated to a specific density. Pressures of 10 to 60 tons per square inch are created by the vertical action of an upper punch or by the double action of an upper and lower punch. Pressing is typically at room temperature, although elevated temperatures can also be used. Core rods are used inside the die to control formation of holes parallel to the direction of pressing. If the part being made is thin and uniform in height, the powder can be pressed from one side by the upper punch. When that punch withdraws, a lower punch raises the part out of the die. The part is then ejected by the wiping action of the powder feed chute, which also wipes powder for the next piece into the die. Ejection from the press can also be accomplished using automated handling equipment. The density of pressed powder tends to decrease along part height as the distance between the compacting punch and die increases. To produce more uniform density, thick parts are compacted by a set of upper and lower punches. After pressing, parts are transferred to the sintering furnace. Sintering furnaces include preheat, high heat sintering, and cool down zones, each having a controlled atmosphere. Depending on the base metal of the part, the atmosphere of the sintering furnace may be endothermic, which is composed mainly of hydrogen, nitrogen, and carbon monoxide. Exothermic, which is composed of nitrogen mainly. Dissociated ammonia, which is hydrogen and nitrogen. Or entirely hydrogen, vacuum, or inert gas. To ensure proper sintering, the heating rate, maximum sintering temperature, time at the sintering temperature, cooling rate, and furnace atmosphere must be closely controlled. Powder metallurgy is a metalwork for producing parts from metal powder. The primary advantage of powder metal parts is design flexibility. Parts can be produced to net or near net shape and to controlled porosity or nearly full density. Most metal powder is produced by physical or mechanical methods. Atomization by high-pressure water or inert gas is the most common physical method. Mechanical methods include milling in hammer, rod, ball, grinding, or attrition mills. Metal powder used for parts production can be a combination of various elemental particles or pre-alloyed powder. The powder is then consolidated in dies or molds, shaping and densifying the powder into a compact of the desired part. The compact, which is in a green state, is then sintered. The common methods of consolidation are mechanical pressing, injection molding, and isostatic pressing. In mechanical pressing, the powder is automatically gravity-fed into the die in a press and consolidated by the vertical action of a punch or punches. Most powder metal parts are produced by mechanical pressing. After pressing, parts are transferred to a sintering furnace, where they are heated to metallurgically bond the individual particles. After sintering, parts may require additional processing in secondary operations. Injection molding involves mixing the powder with a thermoplastic binder and granulating it to produce the feedstock. The feedstock is heated and then injected into a mold to produce the desired part. Once the part hardens, it is debinderized and then sintered. Powder consolidation by isostatic pressing can be performed at room temperature, which is called cold isostatic pressing, or at an elevated temperature, which is known as hot isostatic pressing.
Okay, so we have seen the animation for the process. So we will see now one by one. The first one, Manufacturing of metal powders. How we can manufacture a metal powder? The manufacturing of metal powders. Manufacturing of metal powders. So this can be done by many processes such as atomization, machining, crushing and milling, fourth one, reduction, then electrolytic deposition, shorting, condensation, etc. etc. So we know that the first stage or the first step in powder metallurgy is we have to manufacture the metal powder. First of all, we have to prepare the fine powder of the metal. So how we can make the metal powders? Then these are some of the methods by which metal powders. So we will see one by one. First one, atomization. Okay, atomization. So what is atomization? By the name itself, we can get an idea. That is, atomization. The atom size particles are converted. We are creating the metals into or disintegrating the metals into atom sized particles. How? The molten metal. We are first of all we will melt the metal and convert it into molten metal. Sorry. And the molten metal. So what we do is this molten metal is forced into some orifice. Orifice means small holes. So this is the molten metal is forced into the orifice. Small orifices, and then disintegrated. This is disintegrated by using the compressed air or inert gas. Compressed air or inert gas, or even water jet. Then it will be cooled and spherical particles are obtained. Small spherical particles will be obtained. This is one of the methods by which we can create the atom-sized particles or powders out of the parent metal. So what we do is we just melt the metal, pour it through the orifice or force it through the orifice. Then it is compressed, the air is passed through that or water jet, anyway, anything, or inert gas, even inert gas. Then the spherical shaped particles are obtained. And this is done for mainly low melting point alloys. Low melting, such as brass, bronze, zinc, tin, etc. Zinc, tin, lead, aluminum powders, etc. So for low melting point alloys, we are using this kind of mechanism, that is atomization, because it will be easy to melt, or it will be easy to provide the molten metal with which having the lower temperature. So these kind of materials, that is brass, bronze, zinc, tin, lead, aluminum, etc., which is having low melting point, can be used for producing the metal powder by atomization. So this is one of the method. Now we'll see what is a reduction. Reduction in chemistry and all, we have already studied what is a reducing or a reduction process, right? So by reducing properties or the reducing operation also, we can produce the metal powders. Reduction. So what is reducing? Reducing means whatever we have seen, reducing the from the oxides and all metals or anything. That means we are extracting the metal out of the oxides of the metal. That means, for example, if we want to create the sponge iron powder, for sponge iron powder, one example. Say we we need a powdered form sponge iron. Then what we do is, either we can use the alloy Fe3O4. You can see the reaction, plus 4C gives 3Fe plus 4CO. We can say Fe3O4 plus 4CO, carbon monoxide, gives 3Ce, 3Fe plus 4CO2. Likewise, we can see using certain gases, we are removing the oxygen from the alloy, that is reducing. This is the reduction process. We are reducing and we are getting the pure metal out of that. Okay, and this metal is then crushed and milled to the final powder. Then after the extraction, it is crushed and milled. So in certain cases, we are doing like this in order to make the powder. First of all, we have got with the not pure metal, but some alloys. From that, we are reducing the metal. Then it is crushed and milled to the final powder. Another example is for copper. For copper, Cu2O plus H2 in the presence of hydrogen gives 2Cu plus H2O. Here also we are getting the copper from that. Then it is milled to the final products. So some of the examples for this reduction, that is we are creating the metal powder from their oxides by reducing or by reduction process, are mainly tungsten, molybdenum. Oh, വല്ലാത്ത ലൈഫ്. Molybdenum, nickel, cobalt, etc. So these are all created using reduction process. So first one was atomization. That is mainly done for the low melting point alloys such as brass, bronze, zinc, tin, lead, aluminum, etc. Where the metal or the molten metal is passed through the or forced through a small orifice, then it is disintegrated by using powerful jet of compressed air, inert gas or water. Then we let us move to the next process, that is a reduction process, where the pure metal is obtained by reducing its oxide using certain reducing gases at the elevated temperatures, high temperatures, just below the melting point. So, so that we get the pure metal out of which then it is the final product will be or the powder is obtained by crushing and milling. Next, by electrolytic deposition or through electrolysis. Electrolytic deposition. Electrolytic deposition or through electrolysis. Electrolysis we have seen. What is electrolysis? Electrolysis, we have the main components are we have some electrolyte, and two electrodes are there. Positive and negative. The positive one is internal anode and another one is cathode. Then when a DC supply is applied, then what happens? എന്താ പറ്റുക? ആനോഡ് വിൽ ഡിസിൻറ്റഗ്രേറ്റ് അല്ലേ? ആനോഡിൽ നിന്നുള്ള പാർട്ടിക്കിൾസ് ഒക്കെ എന്താണ് ഡിസിൻറ്റഗ്രേറ്റ് ചെയ്ത് നേരെ വന്ന് കാഥോഡിൽ വന്ന് എന്താണ് ഡെപ്പോസിറ്റ് ചെയ്യും അല്ലേ? അപ്പോൾ ഈ ഒരു മെക്കാനിസം ഉപയോഗിച്ച് നമുക്ക് മെറ്റൽ പൗഡർ ഉണ്ടാക്കാം. എങ്ങനെയാണ്? സപ്പോസ് യു വാണ്ട് ടു ദിസ് ഈസ് മെയിൻലി ഡൺ ഫോർ copper and iron. So in order to make the copper powder, what we do is we place the anode as copper. We keep the anode as copper, and instead of cathode we are placing some other plates like aluminum plate, and the DC supply is given. So what happens is after passing the DC supply, the circuit will be completed, and this is the electrolyte. What happens is the copper will get deposited on the aluminum plates. So the aluminum plates will be like this, aluminum plates, and there the copper particles will be present. Okay. And this will be taken or scrapped, or this copper particle after a particular time period. What we do is we just strip off this copper particles from here, and then it will be washed, dried, and just made some more. It will be pulverized to the final powder. And what we do is we just give some heat treatment also in order to remove the work hardening effect. So basically what is happening is nothing but the metal which is to be made into powder is made as the anode, and what while applying the DC supply, this anode disintegrates, or the metal will get deposited on the cathode, and which will be taken from the cathode by stripping off, and then it is washed, dried and pulverized to form the final powder. Then this powder, after heat treatment, why? Because in order to remove the work hardening effect, we are just, because we are pulverizing, or we are forcing it to thin, small powders, so there will be some work hardening effect. In order to remove that, we are applying the heat treatment process, and after the heat treatment process, the final powder will be obtained. And regarding the cost, this cost is somewhat high. That is one of the disadvantage. Cost will be high. So this is about the electrolytic deposition or electrolysis. Now another one, mechanical alloying. Mechanical alloying. Mechanical alloying. So mechanical alloying. What is a mechanical alloying? Alloying means mixing of two or more metals to form a desired quality product. Right? So for example, for brass, copper and zinc, bronze, copper and tin. Likewise, we are alloying in order to increase the property or enhance the property than the individual metals. So similarly, here also, instead of a single metal powder, we are using a mixture of, or we are creating an alloy by mixing two or more pure metals in a ball mill. So we are taking the metal powders of two or more pure metals, which will be mixed in a ball mill. Then it will be impacted or compacted to form a uniform mixture of this particular final product. And this is mechanical alloying. Next, shorting. Shorting. Here, what we do is the molten metal, like atomizing molten metal. First of all, molten metal. That means we are melting the metal above the melting temperature. So we obtain a molten metal, and this is poured into a orifice or sieve. Sieve or orifice. Sieve എന്ന് പറഞ്ഞാൽ നമുക്ക് അരിപ്പ പോലെയുള്ള സാധനം, or orifice. And this is cooled by dropping into water. ഇത് നേരെ എന്താണ് വെള്ളത്തിലേക്ക് കൊണ്ട് ഇടുന്നു. ഇത് പോകുന്നു. നേരത്തെ പോലെ അറ്റമൈസേഷൻ ആണെങ്കിൽ എങ്ങനെയായിരുന്നു? അവിടെ നമുക്ക് ഒരു എന്താണ് ഈ എന്താ പറയാ, ഒരു ഹൈ എന്താ പറയാ, കംപ്രസ്ഡ് എയർ ആയിട്ടുള്ള ഹൈലി കംപ്രസ്ഡ് എയർ, അല്ലെങ്കിൽ എന്താ പറയാ ഇനേർട്ട് ഗ്യാസ്, അല്ലെങ്കിൽ വാട്ടർ ജെറ്റ്, ഇങ്ങനെയുള്ള കാര്യങ്ങളായിട്ട് നമ്മളൊരു പവർഫുൾ ജെറ്റ് കൊടുത്തിട്ടായിരുന്നു നമ്മൾ എന്താണ് പൗഡർ ക്രിയേറ്റ് ചെയ്തത്. ഇവിടെ നമ്മൾ അങ്ങനെ ഒരു ജെറ്റ് കൊടുക്കുക, അല്ല നേരെ വാട്ടറിലേക്ക് ഇടുകയാണ് ചെയ്യുന്നത്. അതാണ് ഷോർട്ടിങ്. ആൻഡ് ഫൈനലി നെക്സ്റ്റ് ഒരു പ്രോസസ്സ് കൂടെ പറയാം, കണ്ടൻസേഷൻ. കണ്ടൻസേഷൻ ബൈ ദ നെയിം ഇറ്റ് സെൽഫ്. എന്തായിരുന്നു കണ്ടൻസേഷൻ? കണ്ടൻസേഷൻ എന്ന് പറഞ്ഞാൽ എന്താണ്, വേപ്പർ ഉണ്ടെങ്കിൽ വേപ്പറിനെ നമ്മൾ എന്താണ് കൂൾ ചെയ്ത് ലിക്വിഡ് ആക്കുന്നു, അല്ലെങ്കിൽ എന്താ പറയുക ടെമ്പറേച്ചർ റെഡ്യൂസ് ചെയ്യുന്നു, അല്ലേ? അതേപോലെ തന്നെ ഇവിടുത്തെ കേസിൽ എന്താണ്, മെറ്റലിനെ നമ്മൾ മെറ്റൽ വേപ്പറായിട്ട് മാറ്റുന്നു. മെറ്റൽ വേപ്പറായിട്ട് മാറ്റിയിട്ട് അതിനെ കണ്ടൻസ് ചെയ്യുന്നു. അങ്ങനെ കണ്ടൻസ് ചെയ്തിട്ട് അപ്പോൾ എന്താണ്, ഏതെങ്കിലും ഒരു കൂൾ സർഫസ് ഉണ്ടെങ്കിൽ അവിടെ കണ്ടൻസ് ആവുന്നു. അതിനുശേഷം എന്താണ്, അത് സോൾഡിഫൈ ചെയ്ത് ചെറിയ ചെറിയ സ്മോൾ പാർട്ടിക്കിൾസ് ആയിട്ട് മാറുന്നു. ദെൻ ഇറ്റ് വിൽ ബി ടേക്കൺ. അപ്പോൾ അതിനെയാണ് നമ്മൾ അപ്പോൾ എന്താണ്, നമുക്ക് യു വിൽ ഗെറ്റ് എ മെറ്റൽ വേപ്പർ. മെറ്റൽ വേപ്പർ എന്ന് പറഞ്ഞാൽ എന്താണ്, വാട്ടർ വേപ്പർ പൗഡർ. ഇതാണ് ത്രൂ കണ്ടൻസേഷൻ. അപ്പോൾ കണ്ടൻസേഷൻ വരണമെങ്കിൽ എന്തായിരിക്കണം? മെറ്റൽ ഷുഡ് ബി ഈസിലി കൺവേർട്ടഡ് ടു വേപ്പേഴ്സ്, അല്ലേ? വേപ്പർ ആക്കാൻ പറ്റുന്ന മെറ്റലിനെ പറ്റുള്ളൂ. അല്ലാതെ ഇപ്പോൾ അയണിനെയൊക്കെ എടുത്ത് നമ്മൾ കണ്ടൻസ് ചെയ്യാൻ നോക്കി കഴിഞ്ഞാൽ നടക്കില്ല. അപ്പോൾ വോളറ്റൈൽ മെറ്റീരിയൽസ്, വോളറ്റൈൽ മെറ്റൽസ്, വോളറ്റൈൽ എന്ന് പറഞ്ഞാൽ ആവിയാവാൻ അല്ലെങ്കിൽ വേപ്പർ ആവാനുള്ള ടെൻഡൻസി, അതായത് എന്താണ്, ചെറിയ ടെമ്പറേച്ചറിൽ തന്നെ വേപ്പറായിട്ട് ക്രിയേറ്റ് ചെയ്യാൻ പറ്റുന്ന മെറ്റൽസ്, അതാണ് നമുക്ക് കണ്ടൻസേഷന് ഉപയോഗിക്കാൻ പറ്റുള്ളൂ. വോളറ്റൈൽ മെറ്റൽസ് സച്ച് ആസ് സിങ്ക്, മഗ്നീഷ്യം, അതുപോലെ കാഡ്മിയം എക്സെട്ര. ദീസ് ആർ യൂസ്ഡ് ഫോർ കണ്ടൻസേഷൻ പ്രോസസ്. ഓക്കെ, so these are the methods by which we can prepare the metal powders. എന്തൊക്കെയായിരുന്നു? ആറ്റമൈസേഷൻ, റിഡക്ഷൻ, ഇലക്ട്രോളിക് ഡിപ്പോസിഷൻ, മെക്കാനിക്കൽ അലോയിങ്, ഷോർട്ടിംഗ്, കണ്ടൻസേഷൻ. Okay, so your attendance.